Welcome students, we have been given this question. Now let me draw the relevant figure for this question. You got the circle with the center at O and you got 3 points on the circle. You got a point A, you got a point B and you got a point C, and the figure looks something of this nature. And then there are two tangents which are hitting the circle. So let me draw those tangents. The common point is D, and you got another tangent. Okay, so this is 90, this is 90. Okay, anyway, we will come to the question now. Let me write the question down. A, B, C are points on the circle of radius equal to 3 units with center at O. DA and DC are tangents to the circle. Now OD is equal to 6 units. We are expected to find the arc length ABC. So since we have been given OD to be as 6 units, let me draw that up. I'm going to use a dashed line. Okay, so this is 6 units, this is the radius, so OC. So let me start with the solution. We need to give detailed solution to all these questions. Now first and foremost, from the figure, as I mentioned to you, locate the tangents. You got a tangent and you got a radius. You got a tangent and you got a radius. So draw that 90 degree. You need to do this. That's the first step. Next, given that, state that, given that the radius is equal to 3 units, right? This would imply from the center to any point on the circumference, it's a radius. So this would mean OA is equal to OC is equal to R, which is equal to 3 units. So place that 3 units. Okay, so we have done the steps 1 and 2. Now the most important thing is to actually find the arc length of the arc. Okay, you can state the formula. We know that arc length is equal to theta over 360 multiplied with 2 times the radius into pi. I would be representing it in this fashion, 2 pi r. So this is the formula that we would be using. So for this we need to know theta. Now this is the angle which we are interested in. We need to know this angle. Now this angle would represent theta, but to get this angle we need to extract this angle which is located over here. Only if we know this angle we could easily deduct theta. So for that, what I wish to do is I would like to consider the triangle, the first one which you see here, ODA. So you can start off by representing the triangle or by drawing the triangle. Now what I wish to do is I would like to start it off like this. Consider triangle. Probably what I will do is I will just consider starting from OAD because it's a right angle over here. So I will just draw it like that. So now I will exclusively take the triangle and I would actually place the triangle over here for your better understanding. So let's actually do that. So I would draw it in this fashion: O, A and D. Now at A we got 90 degree. We are looking to extract this angle here. So let this angle be some alpha. We don't need to worry about this angle. This is not required. But OD is 6 units. So just mention that 6 units. Now what I wish to do is, I would like to draw your attention to trigonometry. Now if I were to take this as sine alpha is equal to opposite side divided by hypotenuse side. Now when we talk about the opposite side, the side that is facing alpha is going to be opposite side. So this is going to be my opposite side, this is going to be my hypotenuse side, and this is going to be my adjacent side, right? So I'm viewing this figure in this fashion. The side that is opposite to the angle, that's the opposite side, and the side that is actually leaning and holding on to the angle alpha, that is the adjacent side. Of course this is hypotenuse, there is no change in that. So I am taking this, and then if I were to write sine alpha is equal to opposite side, which is x, over hypotenuse side is 6. Now clearly you can see that we are not able to use the value of OA, because OA is, if you can see here, OA is given to be as 3 units. So clearly we are unable to use this value, because opposite side we don't know, we have got no clue what the opposite side in this case, because that is dA. So we got no information pertaining to that particular value. All that we got is the value for the adjacent side, right? Of course hypotenuse side's value is present. So let me go to cos alpha and see what we got. Cos alpha is nothing but adjacent side divided by hypotenuse side. So this is the formula. So adjacent side is nothing but 3 units, and my hypotenuse is 6 units. Clearly observe that 3 over 6 would give us 1 over 2. So from here I can state that cos alpha is equal to 1 over 2. Now we know that sine 30 is 1 over 2, but sine 60 is root 3 over 2. In this case cos 30 is root 3 over 2, and cos 60 is 1 over 2, right? So we are looking for cos alpha. So alpha is equal to, you move this cos to the other side, this is going to be cos inverse of 1 over 2. So cos inverse of 1 over 2, the value of alpha is, in this case you're going to get 60 degrees. So alpha is equal to 60 degrees. So clearly we've got alpha. Okay, fine. So that would mean this part of the angle that we have got, this angle is 60 degrees, but we need to get the entire angle. Now watch here. Now this is 90 degrees, this is 90 degrees, and we got a side here 3 units, and we got a side here 3 units, and then we got a common side that is joining these two, right? Let me just show you. You got an angle, same angle that is existing, that's fine, and then you got a side here and a side here, and then you got a common side. So what can you draw? You can clearly state here by angle side criterion. We observe that. So what is the observation? You can clearly state here, triangle OAD is congruent to triangle OCD. Now because they are congruent, this would mean by corresponding parts of congruent triangle, their values that we see, they would also be congruent. Okay, this is a rule. So the statement is corresponding parts of congruent triangles are congruent. So that is the statement. I've already done a full-fledged theorem on this. Please kindly revisit. So this would mean angle at AOD will be equal to the angle at COD, which is equal to 60 degrees. So what I'm trying to explain here is, this angle is 60, this angle will also be 60. So the joint angle is 120. So therefore the central angle, so this means the central angle would be 60 plus 60, which is equal to 120. This is the central angle. But we need the angle at O. This means, let me use this color. The angle at O, or the angle at O, is nothing but theta. Theta is equal to what? 360 degree minus 120. So what is that? 360 minus 120. This is 0. From 6 you take away 2, you get 4. From 3 you take away 1, 240. So this is equal to 240 degrees. So this is my theta. So we are expected to find the area. So the arc length. Therefore arc length is equal to, in place of theta, it's going to be what? It's going to be 240 divided by 360 multiplied with 2 times pi. My radius is 3 units. So take away the 0, take away the 0. 2 times 3 is 6. 6 divides 36, 6 times, and you can cancel this off. And 6 divides 24 4 times. So this is going to be 4 pi. So 4 pi units is the answer. 4 pi units is the answer. So this is the arc length. If you want, if they are asking you to extract it in significant places, you can write it as 4 times 3.14159. I'm taking this to be the value of pi, so which is equal to, in fact you should use approximation. 9 4s are 36, 3, 20, 23, 2, 4 ones are 4, and a 6, 16, 1, 4 ones are 4, 5, 4 3s are 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is the value. Now depending upon the significance they are asking, you can actually approximate and place the answer. So this is the solution to this question. Students, please like, share and subscribe. Thank you.